video of Siemens PLC programming series, and today we are going to see one application of the counter in the real world. So this is actually what we want to design. So suppose you have a parking, so it has one specific capacity for the car. So for our example, we consider capacity of this parking is 10 cars. So we want to actually design the system that somehow monitor how many cars you have inside your parking. If you have 10 or over 10 cars, so that means you don't have enough space here in your parking, and in the entrance the full light should be on. So if the number of the cars that you have inside your parking is less than 10, so it means you still have some spots for getting more cars. So these available lights should be on. So that means two light. One shows the parking is full, no one could get in, and another one shows the spot is available and cars could be get inside the parking. So definitely you add two sensors. So the main job of the sensor is to make a pulse. So that means whenever one cars get in, so this sensor produce one pulse, and whenever these any car go out, again this sensor sense that and produce one pulse on that. So let's to see how we could design our ladder logic for this specific scenario, which we want to have two light here, which shows us there is the parking is full, or there it has some uh, spot that people go get in. So I already actually designed the system, so let's to just review it and see what we have. So I put one up down counter CTU. So definitely you have two inputs here. The CU is the uh, up counting input. So I connect the entrance sensor, which is coming from the input 0. So that means this sensor somehow work as a this switch that you see. So that means any car pass through the sensor is somehow produce a pulse. Here I simulate that by adding the switch. So that means whenever I toggle switch, it means sensor sense one car pass through. So in the CD, I put the exit sensor. So again, whenever any car go out of the parking, so the sensor produce a pulse. Somehow I produce or I simulate this sensor's job with this toggle switch that I have, so which I connected to the input 1. So that means if I toggle the switch that I have input 0, it means the sensor sends one car. Here if I toggle this sensor, it means the output sensor or exit sensor actually sends some um, passing car. So I don't use the LD, I put just all the time false. IPv is a 10 because capacity of my um, the capacity of my parking lot is 10. If you want to have more, definitely you could change that. So no use of the LD, we just connect the R to the output 2 again with the toggle switch. We just if we toggle that switch that we connected to the input 2, you could reset these value. So no use of the output QU, which is for up counter output. No use of the QD. I don't care what the value is. You see, I don't use any of them. So the value I use here is the current value. So I save that in. If you see this tag number, I use the tag number percentage MW0. So that means I reserve a memory. Its size is the word, and I use MW0 here, which is the number. So I explained this in the separate video, which is the internal memory addressing in Siemens PLC. If you didn't watch that video, the link is in the top of the screen. Please watch that. I'll explain how you could make that. So for this, what I did, I made a whatever you have the value in CV, you somehow save that inside the memory. Its address is percentage MWZ. So that means we checking these place in your memory, PLC memory, you could see what's the current value in your counter. So here in network 2, I use this same value. This operator that you see is, you could actually find that here. So you comes to the instruction, if you click on the instruction, and if you, let's see if I could get that. Yes. So then here you have one folder which is the comparator operation. So if you click on that, it's actually open them, and whatever I use is greater or equal. So see these guy, I use these guy greater or equal. So what these greater or equal do, you set these values. So see, I able to set here value which is 10. So it's actually check these variable that I have, which is the current value. If it is greater or equal to the 10, it somehow turn on these output. So that means if it's 10, so you have the full, or even if it's greater than 10, it's actually turned on. If this current value is greater than or equal to that 10, it's actually turned on. So this output connected to the one light, which is the full light. So that means whenever it is 10 or greater, it should be turned that on. So whenever this is turned on, you use these NOT. How you could get these NOT, I show you. Go to the other section, which is to see, do we have a bit logic operation? So see this bit logic operation, and here you could find this NOT. So this is exactly do the same operation of NOT. If here is 1, here is 0. If here is 0, is 1. Definitely should be that way, right? Whenever your full light is on, so the available should be 0 off. So whenever available is on, the full should be 0. That's the reason you just get for output, you just take a NOT and connect this to the uh, second light that you have, which is the available. So what's happened here? You start with counting, so whenever this number is 10 or equal to 10, if that's less than 10, definitely it is 0. This is 0, which is currently is in that mode. So currently it's 0, so 0 is not greater than 10. Here is 0. If you take a NOT from 0, you have 1. That's the reason now the available is on. So whenever it is 10 or greater than 10, so this is on, the full light is on. If this is 1 or on, so this should be 0 and this should be turned off. So it looks these ladder logic do the job. So let I do one thing, that I turn on the video that you able to see. And again, I'm going to review all the input and outputs that I have in these ports that we have. Let's to review that. So let's to first start with the CU. So this one is on input 0, so that means here is the sensor. We toggling that means toggling this input 0 means the one cars get in. If you do 2 times, means 2 car get in. So input 1, input 1 is the exit sensor, so that means we toggling with means one car goes out, right? This is the cars get in, this is cars get out, and this is the reset. So these Q2 is reset. That means whenever I toggle this is my reset, and my counter number is 0. Probably this is for the time that the parking start to work. If there is no car here, you just reset that. The counter is 0, means nothing is there. So then you start to getting car, and these two should be able to toggle. One for getting car inside, one go out of the park. So then you should have two output, right? So see here you have two output. One is Q0. So these output 0 means full, and this means available. The output 5. So see, this is Q05. Somehow I put the distance between these two that we're able to see. So the 0 means full, this 5, or actually the 4, because we start from the 0. So means actually no, that is 5, 0 to 5. So because the number is 5, so the 5 means you are in available. 5 is available, 0 is full. Okay. So let I see it is working or not. So I'm here. This is early morning. Whenever we are starting we opening the parking, I just reset the counter, so everything should be back to 0. This is 0. This is 0. Now, suppose you get one car inside, so that means the sensor sense that, so you have one. This is one. What's happened here? So the full should be off. So this is full is off and the available is on. So that means people see, okay, that's available. So how about increase that? The second car come in, third one, fourth one, five one. Still, is this one is available, right? Is available is on. How about whenever you are have five car inside, one of them go out. So that means this one should be active. It's back to the four. If I now the second car go out again, it's active. You get three. Now I get two more cars. So the sensor sense that I have four, one more, seven, one more, eight, one more, nine. It's still the available is on, which is this. Okay, so it's work based off what it's supposed to be. Let's to go to the 10 and see what's happened on the 10. So if I'm on the 10, so see if I'm on the 10, so it means this is on, so that means the full is actually on and the available is off. This is what it's supposed to be, right? So now let to some cargo. Let to increase the number. So definitely you couldn't go inside whenever it's 10. So you somehow you block that. Let to decrease that. We have 10 right now. Now one if one car go all out, so definitely the available should be on. One cars go out, see available is on, and the full is 0. Let to test that one more time. So I'm going to reset it is 0. So then cars actually get in, 2, 3, 4, 5, no one go out. So 8, 9, and see whenever it is 10, what it means. Whenever it's 10, it means that currently I have 10 car inside. Now shouldn't becomes the other one because I have a 10 spot. So this number is right. So it shouldn't be 11, it should be 10 because whenever it is 10, you get one car inside. Totally you have 10. So now the full is on, which means you shouldn't get any car inside and the not should be, the available should be off. So it is right. So now see, you have 10 car. If any of them go out, you should actually change these to, so see right now is full is on, which is this one, and 5 is available. If I go and sensor exit sensor sense one card, so see you have 9. So then this is available is on, and this one should be in 0 mode. So as you could see, it's working and exactly able to monitor the number of the cars that we have inside these parking. So I hope you find this video useful and see you all in our next video.